To display a group of images, after cycling to a particular image of a fundamental, left-click on the zero image in a row below the fundamentals. As you display images in a set, the particle type of the subset will be displayed. This subset is an anti-electron. Start your display with the leftmost fundamental and proceed in order. To zero an image with the cursor over the image, click the X button, then click any image you wish to zero. Click X again to end the function. To zero images in a row, click the Reset button. To zero all images, press Escape. To compose a proton, select the T and V groups of the Rishon elements shown above and display in the first row from left to right. To compose a U-quark, first select two yellow T's. Then click the up arrow to get a green V. To compose another U-quark, click the right arrow and select two red T's. Then click the up arrow to get another green V. To compose a D quark, click the down arrow and select two blue anti-Vs. Then click the left arrow to get a purple or anti-T. Use the drop-down box to see the quanta for each quark and compare to those given by the standard model. Note that the electric charge of the T's of the U quarks sum to 4/3, and the anti-T of the D quark is minus 1/3, so the charge of the proton is 1. Note that the isotopic spin of the T's and V's of the U quarks sum to 1, and the anti-V's and anti-T of the D quark sum to minus 1/2. So the isotopic spin of the proton is 1/2. The color of the T's are blue and red, and the color of the V is orange or anti-blue. So the color of the quark is red. The color of the T's are yellow and blue, and the color of the V is purple or anti-yellow, so the quark color is blue. The color of the anti-V's are red and yellow, and the color of the anti-T is green or anti-red, so the color of the quarks are red, blue, and yellow. Therefore, the color is white. For the first U quark, The T's have opposite intrinsic spin, so its spin is the spin of the V group, 1/2. For the second new group, the T's have opposite intrinsic spin, and so its spin is the spin of the V group, minus 1/2. For the D group, the anti-V's have opposite intrinsic spin, and so its spin is the spin of the anti-T group, 1/2. Therefore, the intrinsic spin of the proton will be 1/2. Since the intrinsic spin of the first quark was 1/2, the weak charges of its T and V sum to 0. The intrinsic spin of the second quark was minus 1/2. The weak charges of its T and V sum to 1/2. Since the intrinsic spin of the third quark was 1/2, the weak charges of its anti-V's and anti-T's sum to 0. Therefore, the weak force interaction can only involve the 1/2 spin quark as per the standard model.